Approximately 2 million years ago, there is a possibility that the solar system traversed through dense interstellar clouds, resulting in significant changes to Earth's climate. Greetings, everyone. Today's video will delve into the subject of how Earth's climate may have been influenced by a significant event that occurred approximately 2 million years ago. During this time, it is believed that our solar system traversed a dense interstellar cloud, which had potential ramifications for Earth. This encounter could have disrupted the Sun's protective heliosphere, leading to the exposure of our planet to cosmic rays and hydrogen atoms. Geological evidence lends support to this hypothesis, as increased levels of iron and plutonium isotopes have been observed from that era. To gain a deeper understanding of this phenomenon and its effects on Earth's radiation, atmosphere, and climate, researchers are employing advanced models for further investigation. However, it is worth considering whether these dramatic changes are solely a consequence of Earth's environment or if the Sun's position within the galaxy also plays a role. Without any further delay, let us embark on our discussion. Published in the prestigious journal Nature Astronomy, a recent paper by Merav Ofer, an esteemed astrophysicist and professor at Boston University, in collaboration with Harvard Radcliffe Institute, presents compelling evidence of a remarkable event that occurred approximately 2 million years ago. This event involved the solar system encountering an exceptionally dense interstellar cloud, which potentially had a significant impact on the Sun's solar wind. Ofer and her esteemed colleagues assert that this discovery suggests that the position of the Sun in space may have played a more influential role in shaping Earth's history than previously acknowledged. The heliosphere, a protective plasma shield enveloping our entire solar system, originates from the Sun. This expansive shield, also known as a giant bubble by NASA, is comprised of charged particles known as solar wind, which extends far beyond Pluto and envelops the planets. Its vital function is to safeguard us against harmful radiation and cosmic rays that possess the potential to alter DNA. Scientists attribute the existence of life on Earth to this protective shield. However, as detailed in the most recent study, the heliosphere experienced a temporary compression due to the presence of a cold cloud. This compression resulted in Earth and the other planets momentarily residing beyond the influence of the heliosphere. According to Ofer, an esteemed heliosphere expert, this research paper is groundbreaking as it provides the first quantitative evidence of a celestial encounter between the Sun and an external entity beyond our solar system, which would have undoubtedly impacted Earth's climate. Ofer's extensive knowledge and models have significantly contributed to our understanding of the heliosphere, particularly in terms of its composition and structure, where the solar wind interacts with the interstellar medium, the vast expanse between stars and outside the heliosphere within our galaxy. One of her revolutionary theories suggests that the heliosphere resembles a fluffy croissant, a concept that sent shockwaves through the space physics community. Now, Ofer is shedding new light on how the heliosphere, as well as the Sun's trajectory through space, can potentially influence the chemistry of Earth's atmosphere. According to Ofer, the movement of stars is not the only revelation presented in this research. It also highlights the occurrence of significant transformations. Ofer embarked on this study while she was a fellow at Harvard Radcliffe Institute, where she initially uncovered this phenomenon and commenced her investigation. In order to investigate this occurrence, Ofer and her team conducted a retrospective analysis by employing advanced computer models to envision the Sun's location 2 million years ago, along with the heliosphere and the rest of the solar system. Additionally, they charted the trajectory of the local ribbon of cold clouds, a series of substantial compact clouds primarily composed of hydrogen atoms. Through their simulations, they discovered that the local links of cold cloud situated near the end of this ribbon may have potentially intersected with the heliosphere. In the hypothetical scenario described by Ofer, Earth would have been fully exposed to the vast expanse of the interstellar medium, where a mixture of gas, dust, and remnants of exploded stars, including elements like iron and plutonium, exists. Ordinarily, the heliosphere acts as a protective shield, filtering out the majority of these radioactive particles. However, in the absence of this safeguard, these particles could easily make their way to Earth. The findings of the study are in line with geological evidence that reveals an increase in the presence of isotopes, such as iron-60, 60Fe, and plutonium-244, 244Pu, in various locations, including the ocean, the moon, Antarctic snow, and ice cores from the same period. Furthermore, the timing of these findings aligns with temperature records that indicate a cooling phase. According to Avi Loeb, co-author and director of Harvard University's Institute for Theory and Computation, the impact of our cosmic surroundings beyond the solar system on Earth is a rare occurrence. However, it is quite thrilling to uncover the possibility that our journey through dense clouds millions of years ago may have subjected Earth to a significantly higher influx of cosmic rays and hydrogen atoms. These findings provide a fresh perspective on the connection between the development of life on our planet and the vast expanse of the cosmos. According to Ofer, the local links of cold cloud could have exerted external force for a duration ranging from a few centuries to millions of years, obstructing the heliosphere. The length of this obstruction would depend on the size of the cloud. However, once the Earth moved away from the cold cloud, the heliosphere enveloped all the planets, including Earth. This is the state of affairs that persists to this day. The impact of the cold clouds on Earth, such as the possibility of triggering an ice age, remains uncertain. However, it is highly probable that the Sun has encountered several other cold clouds in the interstellar medium throughout its billions of years of existence, according to Ofer. Furthermore, it is expected that the Sun will come across more of these cold clouds in approximately 1 million years. Ofer and her colleagues are currently engaged in the task of tracing the precise location of the Sun 7 million years ago and even further back in time. The European Space Agency's Gaia mission, which is constructing a comprehensive 3D map of the galaxy and providing unprecedented insights into the movement of stars, enables the determination of the Sun's historical position along with the cold cloud system. According to Ofer, the presence of this significant cloud in our history meant that we were inevitably exposed to the interstellar medium. The consequences of encountering such a vast amount of hydrogen and radioactive substances remain uncertain. As a result, Ofer and her team at BU's NASA-funded Shield Drive Science Center are currently investigating the potential impact on Earth's radiation levels, as well as its atmosphere and climate. According to Ofer, this is just the initial phase. Her aspiration is that this document will pave the way for extensive investigation into the impact of external factors on the solar system in ancient times and how these factors have subsequently molded life on Earth. The funding for this research was provided by NASA. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.